Hello guys, how you all doing? So I'm here at the Cisco Networking Academy. I'm going to answer the chapter 6 activities. Um Pardon me if my dog was barking and barking. She just can't stop. So here we're in chapter 6, the network layer. So we're going to search for the activities again. Oh, where is it again? So here, page 6.1.2.6. So the activity is named IP characteristics. So the instructions says read each IP characteristic, then click connectionless, best effort, or media independent to indicate its delivery method. So right here we have this box here. So we have the IP characteristic. So there is a description shown here. So you will match the description in the IP characteristic into this three delivery methods here: the connectionless, best effort, media, and media independent. So we will be going to click this each of these three. The correct one in this three delivery methods. So the first one is will adjust the size of the packet sent depending on what type of network access will be used. Oh, I think it is the media dependent. So as you can see, if you get it correct, the description will go straight to the correct box that you have picked. And the next one is will send a packet even if the destination host is not available to receive it. So I think it's the best. Oh, I think it's no. Send a packet even if the destination host is not able to receive it. Connectionless. No contact is made with the destination host before sending a packet. Hmm. No contact, so it means it is, I think, the connectionless type. Fiber optics cabling, satellites, and wireless can be used to route the same packet. So the fiber optics cabling is mentioned here. So it is a media. So we're going to answer this media independent. The packet delivery is not guaranteed. So the ones left is the best effort. I'm gonna click that. It's not guaranteed that the packet will be delivered fully without errors. Yeah, big. Okay. So once you finish that, you have a prompt saying congratulations, you have matched the IP characteristics to the delivery methods. Best effort does not guarantee that the packet will be delivered fully without errors. So it's just doing its part. Packet delivery is not guaranteed, yeah, but at least it still gives its full effort for the delivery of the packet. And here in the connectionless, as the word suggests, there's no contact made with the destination host for sending a packet. It's like a transparent thing. And also media independent. It doesn't depend on the media in its own. So we're going to the next. So we're here at the, I think here at the I. So we have this part 1 activity, the IPv4 header fields. So the instructions: read each IPv4 header function and then click the IPv4 header field to which it belongs. So again, we have this box here, the IPv4 header functions. So we have their descriptions. So we're going to click again and match the description from these 6 choices here. So we have here the version, time to live, source IP address, differentiated services, protocol, and destination IP address. So these are header fields. So first we have identifies the priority of each packet. Differentiated, I think it's differentiated service. So in this activity, we only have one for each header fields, commonly referred to as a hop count. So this time to live is related to this count, the hop count. So it's like a timer. Always set to 0100 for IPv4. It's the version. Identifies the IP address of the recipient host. Is this, oh no. Recipient host, so it's the destination. Identifies the upper layer protocol to be used next. So it has this word, the protocol. So it's automatically belongs to the protocol header field. Identifies the IP address of the sending host. Sending host is the source IP. So the recipient host is the okay. I got it wrong at the first try. Again. So right now we're here at the IPv6 part. Okay. Read each IPv6 header description and then click the IPv6 header field to which it belongs. So again, as we always do, we will match this description to the header fields given. So the first one is to suggest that all packets receive the same type of handling by IPv6 routers. What? Okay, so it's the flow label. Yeah, it matches because it is responsible to the flow of the transmission of packets to the IPv6 routers. When this value reaches 0, the sender is notified that the packet was not delivered. So I think it has the limit. The hop limit is always set to 120.110. So it's like the version in the IPv4. Yeah, so it's the version. Look like that. Identifies the application type to the upper layer protocol application type. So I have the next header. The classifies packets for congestion control. So congestion means like there's a traffic in the packet transmission. So the traffic class identifies the size of the data portion. It is the length, payload length. Done here. On to the next one. We have this activity, identify elements of a router routing table entry. So the instructions, a partial router routing table entry is shown. Each section of the entry is identified by a circle letter above it. Select the correct routing table entry section for each output. So right here we have this, the letters A to F. So they possess each of these numbers in the elements of their routing table. So we're going to match whether they belong to this, to each of these, to each of these statements. We're going to check them out. So number one, the elapsed time since the network was discovered. So here in the choices we have D 192.168.1.0/24. So 90 slash 3072 via 192.168.3.1 and 6 3 and gigabit ethernet 0/0. So we have this letter E, which is the time. So elapsed time since the network was discovered. So this is the element that we're looking for. I'm going to click that. And number two, the administrative distance source and metric to reach the remote network. So yeah, I think here as we can see, the this in letter C, we have 90/3072. So it means that it only reaches the 19, the maximum. So it's like it measures the distance and the reach of the remote network. So it's to see how the network was learned by the router. And so we have already E, the C. So what's left is A, B, D, and F. So how the network was learned by the router. This A. And number 4 shows the destination network. So letter J says that it's via 192.168.3.1, so it suggests the destination. So the next hop IP address to reach the remote network. Am I correct or oh? I think we have letter B here, destination network, because it's go This 192.168.1.0, this is like the default address of the network. So the next hop IP address to reach the remote network. So we'll try this letter D. And the outgoing interface and the router to reach the destination network. So this letter F is the interface used by the network. So 10 gigabit Ethernet 0/0. Let's check that. Okay, so we're correct. I think we still have some things. Okay. So now we have this activity called descriptions of router functions and hardware parts. Instruction descriptions of router functions and hardware parts are provided in the table. Drag each router component name to its function description. So we're going to drag this router functions and hardware parts into their respective descriptions. So let's try number 1. Connects routers to external networks usually over a large distance. So we have here the WAN interface, LAN interface, auxiliary port, telnet or association console port. So here we have the WAN, the LAN. So the WAN interface is the wide area network. So this says here usually over a large distance. So this is the LAN, the WAN, wide area network. So a way to remotely access the CLI across a network interface is the remotely access. So we have this telnet or SSH connects computers, switches, and routers for internal networking. This is the LAN interface. So a local port USB or low speed serial connections to manage network devices. We have this console port because it is a local port which is USB or low speed. Yeah, this is used by various devices. So a port to manage routers using telephone lines and modems. So this auxiliary port is used to manage networks by using the telephone line and modems. Check that out. Correct. And we have the last one. So right here we have the router boot process. Drag each of these steps on the left to appropriate field in the table, the right to show the router boot process order. So here we have step 1 to step 4. We'll be dragging this 4 and put them in their proper order. So this is the process where the router's boot process starts. So first, step 1 is the perform post. When a hardware check is performed, and the second one, you need to load the bootstrap to locate the iOS of the system. Next, load the iOS if it is located. Oh no. Well, it's hard to drag this. Hmm, okay, as you can see, after the bootstrap is loaded, it looks the iOS, and if the iOS is found, it will load the iOS. In the end, we have this load the configuration file. So yeah, so we have correctly listed the order of the router boot process. So at the last step, we, we will need to flash the configuration file to set up to set it up like that. I think we're done. Are we done? Are we done? Yeah, I think we're done. Okay, so that's it for chapter 6. And thank you for watching. And goodbye again.